Okay, today we're talking about permutations using nPr. This comes from the Jacaranda textbook that's listed in the comments section. Alright, so permutations are where we arrange groups of objects where the order of the objects is important. Two good examples of this are things like a running race as well as coming to a cash register in a supermarket. The order that you come to the cash register or the order that you cross the line in the running race is important. That's what we call a permutation. Compare this to something like picking the winning lottery numbers. It doesn't matter what order you pick the numbers in, so that's not as important. That's what we call a combination. Just so long as you've got the right numbers is really all that matters in that situation. So let's look at this example. We've got three letters, A, B and C. We want to know how many permutations there are, how many different arrangements there are of those three letters. When we look at the letters, we've got three of them. So for our first letter, there's three options. For the second letter, well, we've already used one, so we've only got two left. And for the third letter, there's only one left. Because we need all of these three events to happen, so it's this one and this one and this one, that's why we've multiplied. 3 times 2 times 1 is 6, which is the same as 3 factorial. Now let's think about another example where we have 10 letters. For our first letter, there are 10 choices, and for the second one, there's 9, and 8 for the third. 10 times 9 times 8 is 720. Right. Another way of writing this, we look at it slightly differently. If we had that's effectively 10 factorial over 7 factorial. I mean, what happens in this situation is they'll cancel out, they will, and so on. Which leaves us with 10 times 9 times 8, which is what we started with. Now, another way of writing all of this out would be 10 factorial over 7 factorial. Let me just come up here with a bit more space. Another way of writing this, 10 factorial over 10 minus 3 factorial. Now, why did I pick 10 minus 3? Because I want groups of 3 letters. I only want 3 of them. So this calculation here, this one here is the same as this one, is the same as these ones here. So what we've effectively come up with is a general format that we define as this nPr. N factorial over n minus r factorial is how we arrange it. N is our group size, our number of objects that we have. And R is our group size. In this case, over here, we have 10 letters, that's N. R, we want 3 of them. R is our group size. Okay, let's have a look at some examples. Worked example 11 in the book is quite a straightforward one. Calculate 7p3. Alright, 7p3 is 7 factorial over 7 minus 3 factorial. That's the general format I used on the previous page. What we're effectively doing here is we have 7 objects to choose from. We want to know how many ways we can arrange groups of 3. So if I think of this slightly differently, n equals 7, r equals 3. Okay. Another way to write this 7 factorial over 4 factorial, because 7 minus 3 is 4. 7 factorial is 5040. 4 factorial is 24. 210. There are 210 ways to arrange 3 objects out of a total possible group of 7. Okay? Next example. Worked example 12. How many arrangements of 3 of the fastest cars are there out of 10 competitors? Now it's important that you've read the question in the textbook, it'll make it a bit easier to understand. I've just summarised it here. Okay, so let's have a think. What is N and what is R? N is the total number of cars we have to choose from. There are 10 competitors, so there must be 10 cars. R, we want to make groups of how big? We want to make groups of 3. So, what we want to work out is 10p3. From our formula, 10 factorial over 10 minus 3 factorial, 10 factorial over 7 factorial. Now, you can put these numbers in your calculator and you'll find out that the answer is 720 ways of arranging 3 cars out of a group of 10. Alright, work example 13. How many numbers greater than 1000 can be formed from the numbers 4, 5, 6, 7, 8 and 9? Okay, we've got a number of things we've got to work out here. What is my group size that I'm starting with? 1, 2, 3, 4, 5, 6. N equals 6. Now R, this is where the question becomes a little bit hard. The question's not that difficult, it's just reading it and understanding what it's saying. I want numbers greater than 1000. So I need a 4-digit number to be greater than 1000. The smallest 4-digit number I could get would be 4567, 4567. That would be the smallest number I can make that would be greater than 1000. So my group size is I'm going to need groups of 4 numbers. But if I have groups of 5 numbers, the number will still be greater than 1000. Or I can have groups of 6 numbers. Because if I pick any of those 6 numbers, it's going to be greater than 1000. If I pick any 5 of them, it will be greater than 1000. And I pick any 4, I'll still be greater than 1000. Okay, so I've got 3 separate calculations I need to do. That's the 4-digit numbers. Or I could have the 5-digit numbers. Or I could have the 6-digit numbers. Notice it's an OR event. I don't need both of these to occur. I just need one of them. That's why we're plussing them together. Okay, so when we work this out, 6p4 works out to be 360. 6p5 works out to be 720. And 6p6 is 720 as well. Add these together. There are a total of 1,800 different numbers that we can make from those 6 digits that are greater than 1000. And the last one. Once again, it's not a particularly hard question, it's just a matter of understanding what the question's asking us. So we've got a team where we've got 10 cricket players. We need a captain and a vice captain. We also need a wicketkeeper, a spin bowler and a fast bowler. So there's 5 different positions that we're making up here. So let's look at this. I've written it out like this because it's in 2 parts. We need these guys. Once those positions are selected, we've got to select these ones. So in the first case, these 2, how many players do we have? We have 10 players because we've got 10 players on the team. What is my group size that I'm trying to select? I want to select 2 players out of that. For this scenario over here, how many players am I going to have? I'm only going to have 8 because I've already picked these 2 out. I've only got 8 left. What's my group size that I'll need? 3 players. Okay. So in this scenario, that's 10p2, and I will need 8p3. Okay, so that's to select my captain and vice captain. That's to select the other 3 players, the wicketkeeper, the spin bowler and the fast bowler. Well, you can work out 10p2 is 90, 8p3 336. Multiply these together, 30,240 different ways of arranging these positions and these positions from our team of 10 players. Okay, your next task is exercise 12D from your textbook.